Good morning, everybody. I think we can start. I see that we have more than 60 people connected now. There are a bit more registered for this teaching. I am Fabio Trincardi. I'm the coordinator of BlueMed. This is the first lesson of the e-training course organized within the pilot action on the issue of pollution, and in particular plastic pollution in the Mediterranean. We have more than 200 people registered for the entire course, and the course will last about 1 month. The speaker today is François Galgani, who is giving the introductory lesson to the problem of plastic and microplastic in the Mediterranean. François is a world-class expert on the problems of pollution at sea, and in particular plastic, and in particular is among the first to raise the attention on the plastic pollution in the Mediterranean region. A few technical remarks. The teaching will be twice a week. The lessons will be either online, like this one, or offline. All the material will stay on the web for you to consult and read it again and browse from it. This teaching, this lesson is going to last about 45 minutes. I'm sure that in the end there will be many questions. I ask the attendees not to put questions on the chat during the teaching in order not to disturb our speaker, but rather use the 10 to 15 minutes that we allocated at the end of the presentation. So all this said, I think we can start. And thank you, François, very much for giving this introductory lesson. Thank you all.
Okay, thank you very much for giving me the floor. Good morning all. I'm really happy to be with you today. So my task is to give you an overview of plastic pollution in the Mediterranean. And so before starting, I mean, really going in deep in the topic, I will probably give some more general information on what plastic pollution in what cause and so on worldwide before we go directly in the Mediterranean and see the different aspects of this type of pollution. Okay, so first, plastic pollution must be considered as part of marine litter. And what is marine litter? We say that it's persistent, manufactured, processed, sometimes abandoned or disposed in the marine environment, including coast for sure. And what is plastic then in? I mean, there are many definitions of what plastic is, but I think that we may just keep in mind that it's what we call synthetic polymers that are made with different alignment of different types of monomers and originating from hydrocarbon and recently also from biomass, and including different type of, such as elastomers, matter fibers, monofilaments, coatings, and so on, paints, and so on. And you do have on the screen, I mean, different example like polyethylene, for instance. Polyethylene is two carbon cycle, and when they're put together, then it's a long chain of ethylene. What is important to realize is that ethylene is a natural product, and polyethylene is a synthetic product. It doesn't exist naturally in the wild. So there is no natural polyethylene. It's just made by man, when ethylene is a natural product. So if the polymer is degrading at sea, it may take a long time, I mean, years, centuries in some cases. But at the end, we come back to the state of monomer ethylene. That is natural. So at the end, there is no risk with the component of the plastic, except if you consider additives or other types of, I mean, colors and so on that may be linked to. Another example is the polypropylene. This is exactly the same with different uses. Polyethylene, for instance, is used for plastic bags. Polypropylene is more to, I mean, pieces of plastic, you know, like toys, it's kind of thick plastics. PET, polyethylene terephthalate. You see it's a polymer of this molecule here. And it's mainly for bottles. All bottles worldwide are made of polyethylene. When polystyrene, you know exactly what it means. It means this kind of box, fish box is used by fishermen, for instance. So you see the different types of application with plastic. So what's the situation worldwide? So the problem is that plastic is good in terms of uses, but I mean, it's the end of life of plastic is a real problem, and there is a problem of mismanagement. So you can see a map of the world, and with different plastic produced. I mean, this is the side of the different figures, and then the part of this production that is mismanaged at the end. And you can see, for instance, that in Southeast Asia, China, Indonesia, Sri Lanka, and so on, that a lot of plastics may come to the sea because of mismanagement. And it's a real problem because some countries don't manage the end of life of plastic, and that's the reason why it's littered everywhere and it comes then to the sea. So in the Mediterranean, it's not a question of knowledge, but it's more a question of economy, the state of economy and investments. So some countries maybe felt like late in terms of developing infrastructures to prevent from littering, but also it's linked to the level of population. If you go I mean, it's quite easy to understand that Monaco will release far less plastic into the sea than when you compare it to a larger country like Egypt. And so it's more or less linked directly to the population. If you have a lot of people, you have a lot more sources and you have more debris and it's more polluted. And then it may be dispersed in the Mediterranean Sea. So the Mediterranean is highly affected for different reasons. So you can see here the plastic inputs to the oceans, but from sea-based sources. And it's not from land. If I come back to the first slide, it's quite important to know that there is actually about 8 million tons of plastic that are dumped in the sea every year. And if you calculate it for the Mediterranean country, it will be in the range of 200,000 tons, 200,000 tons of plastic that is going to the Mediterranean Sea. Sea-based sources are also very important. So fishing, for instance, is important also in the Mediterranean Sea. But you have coastal inputs, then it's directly linked to the riverine inputs, and then to the population. And then you have also watersheds and shipping that is everywhere. And unluckily, the Mediterranean Sea receives about 30% of the maritime traffic is going through the Mediterranean Sea because of the shipping routes between Gibraltar and the Suez Canal. And that could be a problem. It's also because the litter that are coming from and the plastic that is coming from ships may not go out of the Mediterranean Sea because there is no exports. I mean, litter plastics cannot go into the Suez Canal to the Indian Ocean and cannot go in the Atlantic Ocean because litter is more either on the seafloor or floating. There is not so much in mid-water. And floating, the current is always entering in the Mediterranean when the layer of water that is going out of the Mediterranean is in the deep. And since plastic cannot sink that much, so it's impossible for the plastic to go out from the Mediterranean Sea. So the production of plastic is now at the level of 400 million tons, and it will continue to grow because we do consider that plastic is very important for economy. And in a way, it's true. I mean, if, for instance, you have, you see this kind of mask for the COVID, for instance, they are made of plastics, of polymers. You see some wings, they are made of composites that include plastics. And wings in a plane, it's make the plane lighter, so it's mean less consumption of fuel, kerosene, and it's also lighter, so less emission of carbon. And so in surgery, for instance, we use also plastic to replace bones and so on. So it's really useful, and in a way, it's quite interesting. The problem again is not the plastic itself, but the end of life of plastics. So I already said that it's 8 million tons of plastic in the ocean and 200,000 tons just for the Mediterranean Sea. So again, why the Mediterranean Sea is really affected by marine litter? This is one of the most affected in the world, if not the most, because the population is very high. In many countries, they are living by the sea, because it's a closed basin, because of maritime traffic, because it's also the first touristic destination in the world. It's in the range of 300 million tourists coming in the Mediterranean Sea every year. And we do have also some large rivers. The Nile, for instance, is one of them, but the Po River in northern Adriatic is also very important in terms of inputs. So by consequence, we do have, when you look at the numbers, they may be really impressive. So it's about 500 kilograms, half a ton every year generated of solid waste generated per person. It's about 200 tons littered every day in the Mediterranean Sea. In some cases on beach, cigarette butts may reach 40% of stranded litter on some beach only. It's not everywhere, but it's in some cases, cigarette butts could be very, very important. And then there was a paper that was published by an Italian team, and we did also have some experiments. I will show you some image later. And the density were found above 1 million items per kilometer square. So it's really accumulating in some place. And this is a characteristic of the Mediterranean Sea. In the eastern part of the Mediterranean Sea, a team from Israel, they found the highest density of microplastics known at the moment. And one station at more than 60 million items, pieces of microplastics per kilometer square. So in some cases, it's really a problem. And this is the reason we do have a lot of things. So you can see the waste generation in tons per person per day on the left. On the right, you have the amount of plastics in tons generated, littered, and going to the sea every year. So this is by country, and you can see, as I was explaining previously, that if you look at Monaco, the inputs is in the range of 60 tons every year. But if you look at Spain, for instance, that will be 30,000. If you look at France, where is France? That will be 11,000. And so you understand that, for one country, it could be a problem because it's for sure too much of littered plastic that is going to the sea. So we have some knowledge about the amounts. And what is interesting to understand is how plastic is important as part of litter. In fact, we know that plastic is something like 70–80% of litter. And in plastic, single-use plastic may reach 40–50%, sometimes more, 60%. And so it means that single-use plastics could be in the range of 30–40% of litter. And so if you want to reduce plastic at sea, the best is to focus on single-use plastics. So it's different types of litter. And if you look at the main categories we do have, we will have a look later, you will see that these different types of single-use plastic, like plastic bags and so on, are very, very important. So land-based litter, it's about 70%, and maritime-based source, remaining part, makes that in the Mediterranean, land-based is more important than sea-based. So just some examples. Just the Po River, the inputs may reach 50 billion particles every year. And we do have a problem also in the Mediterranean. We have some countries with less than 30% of control discharge that are controlled. And we may have inputs from ships at the level of 1 million tons every year. And these are worldwide. It's important. 1 million tons could be worldwide and not in the Mediterranean Sea because it's not well known, in fact. So we have different types of different sources. The rivers are the main important. You can see, for instance, is in the middle. This is a discharge that is by the sea. It's in Lebanon. And they are trying to solve that problem. But I mean, I did so myself, some bulldozer just pushing all the litter directly to the sea. Fishing is also an important source. Lost containers could be an important part some places. And microplastics could be also found directly on beach, lost from shipping, for instance, or from industry. So I mean, we have a lot of different sources. And this is very important because the sources are more or less diffuse. We are 300 persons living around the Mediterranean Sea. So it means 300 million sources of plastics because each of us is able to lose one plastic in his life, maybe 2 of them anyway. And at the end, I mean, if you can master and treat the water coming in a wastewater treatment plant or in a river, you cannot manage, I mean, 300 million sources together. And this is the problem. Because the sources are very diffuse and not mastered, it's complicated to solve the problem. And that's the reason it's accumulating them in the water. So you can see that this is a work that was published in 2007, sorry. And you can see the link between the number of items found on the beach and occupation by tourists. It was in Spain. Martinez Rivas did publish that. And it's interesting that tourism is also, to show that tourism is also bringing a lot of plastic to the sea. What is interesting also is that we did have a change in terms of items found in the Mediterranean. For instance, you can see the difference between 2009 and 2013, during a period of 4 years only. The work was done by Ocean Conservancy. And you can see that cigarette butts has been increased recently, but glass bottles has been decreasing. You see, and cans, metals has been decreasing. So there is less glass bottles found at sea and less cans, but I mean, plastic bottles, because of management, has decreased also, but you can see that butts, cigarette butts have been increased, and also some plastic bags and so on may have been increased. Not only just grocery, but I mean, single-use plastic in general has been increased. Then where the litter is going, so it's quite easy to understand, it goes everywhere, in all compartments of the marine environments. It goes on beaches. This is, you see on the top left, this is a beach that was found. It is an urban beach, but it is a beach found in the southern part of the Mediterranean years ago. You can see the example of cigarette butts, but it goes also floating everywhere, and it goes on the seafloor. In fact, 95% of 95 between 95 and 98% of plastics and marine litter in general is on the seafloor. So what you see is like the part of the iceberg you can see, but in fact it's far more on the bottom, and it's quite important. So this is here an example of France. I mean the top of the slide, and it was after 10 minutes of trawling some years ago. It was close to the Côte d'Azur, and on the right this is a picture of litter accumulating on the bottom. It was also on the Côte d'Azur. So you see it goes everywhere. So there is some research to understand where it goes. So these are examples of work. The one from Suaria, an Italian scientist, assessing floating litter in the western parts, northern Adriatic also on the seafloor. We do have now some results about trends, and in fact, it's very strange, but it's not really increasing. It's variable. You may have some period where it's increasing, then it decreases, and so on. So it's something like a steady state, and we don't know exactly where the litter is going and where the plastic is going, and probably we may find one day accumulation areas on the seafloor of the Mediterranean Sea. We know that they are accumulating in canyons, but we don't know exactly where they are going all. And we can expect that some scientists will find hotspots of accumulation in the deep, in some trenches, you know, and these kind of things. But it's just something like we have to find. So there is some work done. So these are the top 10 items by country. And you can see that, the top 10 may change depending on the country. For instance, glass bottles are quite important in Egypt, but cigarette butts are quite important in Croatia, for instance, or Greece or Turkey. Plastic bottles are more important in Egypt also. Caps are found mainly in Turkey, so you can see the difference in the top items found depending on the countries. So it means also that each country will have to manage the litter differently depending on the uses and the way the people are behaving. So the problem is that litter is degrading and plastic is degrading slowly. And you may find after some degradation what we call microplastics. So if you go at sea, you use a trawl net. This is these pictures on the map. After sometimes 10 minutes, 1 hour, any period, then you will find that the collectors of the nets, what we could call a soup of plastics. You see, these are different collectors. And if you go under the microscope, this is here what you will see. So you will see granulated pellets around, you will see fibers, you will see pieces of different colors, shapes, and so on. And so this is well representative of the different types of microplastics. And if you go then under the electron microscope, you will see that these plastics are degrading, but it takes time, and you will see some fibers. So it's complex because we have different types of shapes, uses, colors, and composition. It could be polyethylene, it could be polyethylene, terephthalate, low density, high density, and so on. And so at the end, there is no uniform homogeneous distribution of plastics, and not only by place, but also by composition. And it's also very important in terms of recycling, because most of the microplastics found at sea are degraded and not recyclable. It's very expensive to reuse. And so it looks like what we lost at sea will remain there for many, many years. And there is no way to recover, except in certain cases that we will discuss later. So the budget for the Mediterranean Sea, it has the level of 250 billion floating particles, actually. Okay, so litter is also moving, and it's quite important because imagine that, for instance, Tunisia takes some measures and stop the production of plastics and the use of plastics. So Tunisia will not pollute, or any other country will not pollute, but because of the currents, I mean, this country and the country that will not generate plastic will receive by the sea from the other country. And it's quite important because you may be covered. So for instance, France, we do receive from Italy in Corsica and the Côte d'Azur. But because of the wind, the Mistral, we do send to Sardinia. So the litter we do receive, then they may come back to Italy. We also send to Spain from France, but I mean, we're receiving the Atlantic from Spain. So it's something like an exchange. I know that because of the currents, I mean, the countries from Northern Africa, so Morocco, Algeria, and Tunisia, will receive from France and Spain, but we'll send them to Italy because of the current. So the litter is moving like that in the Western Basin. It's moving along the coast of Croatia, Montenegro, Slovenia to the north of Adriatic, and then along Italian coast. And in the Eastern Basin, it's going along Egypt and then to the north. So Lebanon at the end, Syria, and then Turkey, and may come back. And so it means that, I mean, litter is moving, and you may check the origin sometimes, understanding, I mean, if you find, for instance, a French debris along the coast of Algeria, it's not sure that it comes from the coast of France, but it may come from a French ship. And so it's really complex to understand exactly where they are coming from and to give the sources, in terms of nationality and so on. But it's true that, and what it means that if you want to manage the problem of our litter, you must have all the parties together. You cannot solve one country only, cannot solve the problem. One town, one city alone cannot solve the problem, because if you clean the beach, all the beach, you will receive from the sea. And so at the end, it must be coordinated, and that's a big problem because we have to tackle marine litter all together, all countries together. I mean, down you have the prediction of stranding. So you can see that some areas may be really affected by the stranding, especially we know now that the Eastern Basin is really affected. And for microplastics, the modeling gives some accumulation areas. Models must be refined. We are not really mastering them, but I mean, we do have a lot of information of interest. This is the work from CMCC. And you can see where the litter is accumulating. For instance, southeast part of Turkey is receiving a lot. And on beaches, you can see that some areas also are really. So we can predict. It must be refined, and the amounts are not really real amounts. It's complicated to know exactly what is coming, but I mean, in terms of processes, it's true that models can help to understand where they are going. We do have then some regional differences. So what type of impact do we have to face? So it depends on, I mean, the types of litter, nanoparticles, microparticles, large litter, and so on. It depends on the size, for sure. And then it may affect the environment at different level of organization, from molecule, for instance, but also at the organism level. For instance, ingestion of marine litter is the impact is more individual than at the population level, but also global. The best example for global was the transportation after the tsunami in Japan of around 300 species, new species for North America that has been traveling across the North Pacific Ocean. In 6 years, it was 290 new species for North America. We know that it has been demonstrated, mixing, DNA mixing, and so on. So an impact at the global level, and without any experience for now, and a risk for that biodiversity that is very, very important. So it's really complicated to manage the impact because it's really diverse. And but we know that entanglements, ingestion, and transport of species are the most important environmental impact. You may have also the release of contaminants, and but if there is contaminants, if there are contaminants on plastic, it's because there are contaminants in the water. You may have some components like additives, for instance, but we know by experience that these are released very quickly at sea. So plastics that is far away offshore don't have so much additives anymore. They still have some, but I mean, the levels are very low. And in terms of toxicity, the levels of additives actually, maybe it will be increased in the future, but actually are not so important. So the release of chemicals is a real process, but it's a minor process. But entanglement, for instance, is very important because in fishing grounds, where fishing is important, then you have a lot of, I mean, fish stocks may be altered. There was a European project some years ago named Fantared, and they demonstrated that about 3% of fish stocks were lost just because of entanglements by lost fishing gear on the bottom. Ingestion also is very important. So you can see different images. This is in a bird. This is in a turtle. So ingestion is very important. And we have some places in the Mediterranean Sea where sea turtles, 80% of sea turtles in the Western Basin are affected by, I mean, plastic that have been ingested. So the reason is that some species are very exposed, like sea turtles or some birds. Sea turtles is because they cannot distinguish between jellyfishes, the natural food, and plastic bags. And as a consequence, some species are far more affected. But it's very important to understand that normally what has been ingested will be excreted for most of the litter, except in some cases like the fulmar, I mean the Procellariiform. It's a family of birds. They have a special pocket in the stomach where they may keep all the pieces of litter ingested. This is the guts, intestinal guts, transit of particles that are dye, fluorescent dyes, and we show that, I mean, they keep in the intestine and then they are excreted. And you see the same for copepods. They are ingested. If you give them some plastic particles that are fluorescent, you will see that they keep in the digestive tract, and then they are digested. And this is very important. For plankton, it's about 2-3 hours to excrete all the plastic ingested. For mussels, it's about and oysters, it's about 2-3 days to excrete most of the plastics that has been ingested. And for sea turtle, it's about 2-3 weeks. For instance, if you find a sea turtle that has been injured in the wild, you keep it in the rescue center. After 2-3 weeks, you will see all the plastic that will be just excreted in the tanks. So we know exactly the residence time, and so it may switch from hours to weeks. But the most important is that it's lower the risk of trophic transfer. If one predator is ingesting its prey that has microplastics, then it will ingest microplastics. But himself, the predator, it will also excrete. And at each step of the trophic chain, I mean, most of the plastic that has been ingested will be excreted. And if there is if the risk of trophic transfer is very low, it's important because there is not so much risk to have plastics in your food from the seafood. So you may have from mollusks, for instance, because they are filtrating a lot. But from fish, not only, I mean, they will not keep the plastics in the stomach, they will excrete them, but also, it's very important, you don't eat, I mean, digestive glands, more or less, except for very small fishes that are created. You know? And so it means that we understand that you may ingest by mistake some microplastics and through the seafood, but it's far less than what you could ingest from the air by breathing. There was a study that was presented in the meeting in Canary 1.5 years ago, and they were saying that the plastic from the seafood is just 5 to 8% of the plastic ingested. In fact, 10% is from drinking water, and 85% is from breathing in the air, because plastic, you know, is in the air. There was a paper published in Science this week indicating that just in the United States national parks, the national parks will save something like 1,000 tons of plastics from the air, raining from the air every year. So you can imagine what could come to the Mediterranean Sea regularly just by, I mean, transportation in the air. So this is a real question. There is no answer now, and I'm sure that in a few years we'll have the information about the level of microplastics that are coming to the sea from the atmosphere. Okay, this is a review of the work done on impact. It was done within the project Panacea that was funded in Interreg. And you can see that we do have some areas where there is, I mean, much information, when in some other, because of, I mean, it's complicated to work there, or, I mean, they were not involved in the project and so on. But in some areas, we lack information on impact. This impact covering the different types, I mean, ingestion, colonization, entanglement, and other. So we can consider that Marlita has a real impact in the Mediterranean Sea, but it's selective. Transport of species, I gave the information about the transportation for thousands of kilometers through the plastics in the ocean, and in the Mediterranean is the same. So we found on large debris some organisms on large debris, but we found this is a species that it's a foraminifera, it's a unicellular organism, and normally it's a sexual reproduction, but sometimes we do have sexual reproduction, and the duration is for 2 weeks. It's in September, and when the sea temperature is at 18 degrees, and this species, Rosalina is her name, is proliferating, is blooming, and normally it's a benthic species, and she fixed on plastic that is at the surface of the sea. And it's very strange because of plastic, this is a case where benthic species normally are living on the bottom of the sea, are then colonizing the pelagic environment, the surface of the sea. And so this is an example. Another example is this one at the bottom. This is a toxic Ocentromicans. This is a toxic dinoflagellate that may become toxic sometimes. So you may know that, I mean, for public health, we do follow the quality of the shellfishes, and sometimes, I mean, we do have problem with toxic dinoflagellates. It's a very common problem, and it's because of one species, usually Alexandrium or Dinophysis or Centrum, this kind of species. And we know that all these species are fixing on plastics. So it means that if there is a lot of microplastic, then I mean, the spread of the toxic dinoflagellate could be facilitated. So this is an example of the risk. And also we demonstrated that the virus that was the cause of mortality in oyster cultivation, including in the Mediterranean, is also settling and fixing on plastic. Okay, where are the challenges in terms of research? You will have some presentation later, other conferences describing more in detail, but what we would like to understand, what the scientists would like to understand better, is if it's possible to have cost-effective methods. I mean, for instance, accumulation areas along the shores. If it's possible to have automated sensors, we have some experiment there. Also, risk assessments. For instance, you have the distribution of sea turtle here. If this is a distribution of marinitter, these were evaluated by plane aerial surveys. And if you cross-map the distribution of both, then you will have the area where there is a risk of encounter. So we are able to evaluate the areas in the Mediterranean Sea where there is a risk to for the organisms to meet the plastics. There is also another typical work done on this topic by the team of Salute Dero in Balearic Island, where they also propose at the scale of the Mediterranean Sea areas at risk for fish, for instance, and so. So also the challenge will be to assess small size particles, and easily. Actually, there is no method to go very fast, and because we are working at the oceanic scale, it's complicated to manage a lot of samples, and the idea could be to, I mean, having automated or semi-automated method to assess very quickly and measure the quantity very quickly of plastics and microplastics. Better understand harm. We know that, for instance, the birds are crafting their nests, preparing their nests with some litter. So it could be used as an indicator. We do have some results on that, but it could be also used more largely. And then we do have some other challenges. I mean, modeling, for instance, predicting where in details, because we do have large-scale model actually, but understanding where they are really going in detail. We do have a new approach, like there was a paper published in Nature some weeks ago about quantification of by a satellite of some types of debris, the large one. And so we are on the way. It's possible that in some years we'll be able to assess plastic pollution, at least for large debris, but by drone it's possible also. And then what is the amount of debris, the types of debris that are coming from wastewater treatment plants, WWTPs. And this is a real challenge, and probably the tertiary treatment is quite important and will come in the future. We do lack infrastructures in the Mediterranean Sea, and we think that one of the problems for microplastics is to better manage the amount in the water. Also, data management is quite important. The Barcelona Convention is considering to set up a new database, and European Commission for European countries also is doing. So we do have also socio-economic impacts. I was explaining that, I mean, we may ingest, even if it's a low amount, plastics from seafood. It's a low amount, but it is. We have the cost of cleaning in some areas. We have also the problem of injuries, metal and glasses, for instance. It's really significant because of tourism. It's a lot that are coming on beaches. We have the cost for fishermen that have to clean the nets, that have to repair the nets, that have to avoid any problem when trawling. And we do have also some spills. There was one, I think, in Greece 2 years ago, a small one, but it becomes more common after the black tides, because of oil. green tide because of algae, and now we have the white tides because of plastic. In some cases, it's the case in Hong Kong, but it may happen because of shipping in the Mediterranean also. So Barcelona Convention, they did list the type of impact we may have in terms of economy, and typically beach cleaning is a lot of money. Health risk is quite important. Publicity, I mean, if it's, an area is dirty, you can be sure that nobody will come and swim. Tourism, then it could be a registered revenue. And then the cost of cleaning by NGO is very important also. The volunteers' times. And then for fishing, repairing, replacement of lost gear, it's a lot of money. And then sometimes we do have reduced, but also contaminated catches. These are the main, but beside we have a lot of impacts. You see, for instance, the aesthetic impact is very important, and the removal in the industry also. And what we don't know is the degradation cost, what we call ecosystem services, and the cost of parameter for ecosystem service is not well appreciated at the moment. Okay. So I was explaining previously that it's complicated to manage, I mean, the diffuse source because of the number of persons that may be responsible. So we are 300 million people in the Mediterranean Sea. It may be 3 million sources of litter, but sometimes, I mean, we may find some solution, but there is no unique solution, and that's a problem. And we must have something like a mix of solution depending on the place, on the country. So you may, I mean, use barriers in rivers. That's been done already, and you may recover some of the litter, preventing them to go at sea. You may organize cleaning, but the problem is that it's just asking people to clean, and then the litter comes back again, and it's not really a permanent solution for sure. You may, I mean, have social behavior, cleaning your area, for instance. You may try to collect fishing for litter, for instance, at the surface or on the bottom. In some place, because of the revenue from tourism, you have to clean. You have this kind of pelican boats cleaning the beaches, for instance, and you may just have some bin, for instance, on beaches, and it's really useful and it works very well. You have this kind of situation in France, and it works really good. And then you have the prevention. I mean, improving recycling, improving wastewater treatment plant, banning, and so on. A lot of other initiatives we may discuss later. There will be some presentation on that, so I will not go in detail. So who is doing what in the Mediterranean Sea? We do have a lot of convention, agreement, and so on. MARPOL, London Convention, BAL. BAL is important because they did include plastic as a dangerous components last year. And so it means that transportation of plastics now is regulated. There are more rules on that. It's possible for one country to decline, to refuse, I mean, admitting plastic from coming from other countries. So it may change, I mean, the way plastic is treated and or recycled. So then we have in the Mediterranean Sea, more global, we have UNEP and the Regional Action Plan. So in the Mediterranean Sea, it's a very important driver. This is a convention of Barcelona that is doing the things, and it's Regional Action Plan to attend on the pollution. So they are trying to coordinate all action and also generating and following and initiating some reduction measures and also information. You have global initiatives like the G7, G20, some countries only, but I mean it's a large part of economy. They may help in some cases. For instance, in the Southeast Asia, G20 is streaming the funding from the World Bank, and it works well because they did have a lot of things done for marine pollution. You have UNEA and the commitment of 200 countries to decrease the level of plastic emissions. And then you have in Europe, so it's northern part of the Mediterranean Sea. It's not covering all, but I mean the BlueMed itself, the BlueMed project from the European Commission is one of the initiatives, and the MSLD is also one, especially for monitoring and supporting regional measures. So what is done within MSLD is also helpful for the Barcelona Convention to manage the litter issue. So you can see, for instance, some of the solutions proposed by the Barcelona Convention. So they are working on post-reception facilities, also fishing for litter, removal in some case, recycling and so on. So they do have a lot of initiatives. I mean, there is a new project that is starting now. Some other measures, so cleaning, for instance, in the waters and so on. They are recommending smart production. And the standard monitoring program is an important part of the regional action plan. And so within MedPol, it's named IMA, Integrated Monitoring Action Plan. And then Europe also is supporting a lot of things in for marine plastic pollution, including in the Mediterranean. So there is the Marine Strategy Framework Directive that is managing monitoring, funding different types of research projects, waste and port legislation that is the revision, regional cooperation that is very important. The BlueMed project is one of the project, and the plastic strategy to ban plastic, single-use plastic that was launched last year. It's important for European countries because it is the fastest directive in the story of the European Commission. In just 7 months, everything has been completed and the directive has been launched. And now there is some, the implementation has been started, and we are on the right way. I mean, member states are already banned the use of plastics, and some other non-European countries are doing the same also. And so I think that it's a good boost to tackle marine pollution in the Mediterranean Sea. And then we have what we call the mission, healthy ocean, coast, and also fresh waters and lakes. And this mission is within the framework Horizon Europe that will start next year. And it's very important because we support a lot of scientific initiative, including citizen science. And there will be normally, because it's just under the, it has been submitted, the mission topic has been submitted, is under agreement. It will, agreement from the European Commission will come soon. But I mean, there will be a focus probably on the Mediterranean Sea and then plastic pollution. Okay, so I will not go in details in the international context. We have a lot of initiative, Ocean Decade, Global Observance System, all Regional Sea Convention, CMR in French, Convention des Mers Régionales. They are working together for harmonized monitoring. World Ocean Assessment is the report of the United Nations on the situation for marine G7, G20. So you see that because of the social demand, the political agenda is very heavy with a lot of things that are starting. I understand that it's just starting, so it may need years before it will be useful and effective. But I mean, it started already, and then when it becomes political, we have more chance to have some good results. So for the Mediterranean Sea only, we have two drivers. I was explaining that before. So the Regional Sea Convention, you have the European Commission, you have the different DGs, DG Mar, DG Environment, DG Research and Innovation, FEDER, and Interreg, that are funding research project and management initiative and so on. And you have so the MSLD that is important, and also the BlueMed project that is also supporting different parties against marine pollution, plastic pollution. Okay, I would like to thank you. Before I finish my talk, so in the document you will receive, there are some links about information about monitoring, European Commission, UNEP-MAP, what is doing UNEP-MAP in the Mediterranean Sea. So there is a lot of information. And then I will switch the presentation to a movie. And so I will go, okay. So imagine you go in the deepest part of the Mediterranean Sea. So we are here in France, offshore. It's about 10 kilometers from the coast. It's 2,200 meters deep. And this is what the bottom of the Mediterranean is. You can see So we are 2,200 meters in the deep offshore the Côte d'Azur, and this is where plastic is accumulating. So at the surface on beach you can see part of, but most of the plastic is on the bottom. It's everywhere in the Mediterranean. It's the same in Italy, Spain, Eastern Mediterranean, everywhere. Each time you have a big city and a canyon, in fact, or some trench just in front, then the litter will accumulate. And you can see that we did check in details, and we found some brands that has disappeared since 30 years, are still there. So we know that, I mean, the litter will stay for decades there, different types of plastics. And this is exactly the situation of the bottom in the Mediterranean Sea. It's not everywhere, but it's very common to find this kind of accumulation. Once again, it's not everywhere like that, but it's very common to find this kind of situation. I thank you very much.
Thank you very much, François. I would like, after thanking you, to apologize with some of our participants because actually it happens that some of them cannot properly hear you because there was this video in the promotional video in the background and in loop, but I also do hope that many of them managed to listen to you and see the presentation, and I would like to invite the audience to make a question by using the questions box, so that we can address to François some of the question. At the same time, I would also like to remind that everything, the recording of this session and the presentation by François will be uploaded online on our website, where we will also open a forum tool where participants can continue to interact among themselves and in case address some question for the presenter. I hope there are some questions for François in order to pass them to him. Okay, first one. Thank you, Maria Teresa. Is there a quantitative estimate of the impact of marine litter, for example, plastic island, on primary production in terms of carbon export, for example?
No, there is nothing. We know that there is a question about the role of plankton to transfer the plastics to the bottom, but it's just speculative. There is no assessment, there is no count. We know that it's very complicated to find microplastics in the midwater. Most of them are floating at the surface or on the bottom, but there is not so much information on the links. I know that there are two papers, not in the Mediterranean Sea, trying to link with primary production. The link that could be possible is that because of the currents, I mean, plastics may accumulate where the plankton is. This is the only information that we can guarantee. That's all. But there is no in-depth evaluation of the links and carbon export and this kind of information.
Thank you. The second question by Daria Vasilevskaya. I hope I pronounced it well. I was wondering if there are any programs of collaboration of scientists with environmental lawyers.
I mean, first the scientists did evaluate the problem, and now the lawyers are coming too. Lawyers are more on the reduction measures. I mean, the ban, for instance, of plastic bags and so on. This is the work. This is paperwork and more or less made by lawyers. But the direct link is not so well done. I know from my personal experience that when there is a law that is coming on the desk in France, for instance, the law of biodiversity, they do have some decrease related to marine pollution. They ask scientists to review, but I mean, more or less, these are separate, more or less separated, yes.
Thank you. Can you repeat the name of the benthic foraminifera that sits on plastic debris? Can you provide a reference for the scientific study?
Yes, I mean, there is a description of the phenomena in the report number 48 or 46 from the CISM, Commission internationale pour l'exploration de la mer Méditerranée, qui est basée à Monaco, that is based in Monaco, and the name of the species is Rosalina. There is a chapter dedicated. The work has been done by a team of specialists for foraminifera, and it has been published in 2016. The report, you can go to CIESM.org, and you will find, I mean, the link to the report.
Thank you. Let's pick a couple of more question. I had one by, okay. Is there standard and agreed by biota selected in Mediterranean to be used as a bioindicator for microplastics? And I'll address the second. Are marine litter more dangerous than wastewater? I mean, toxicity and mortality.
Okay, so about indicator species, the Marine Strategy Framework Directive is asking, it's not mandatory, but is asking to assess impact, and they do select indicator for large debris. This is a sea turtle in the Mediterranean, and also Medpol and the Convention of Barcelona that provide a recommendation for pilot scale monitoring using sea turtle. But these are for large debris. For fish and microplastics, we know about the species to use, like boobs, for instance, or even mussels, for instance. So we know what are the indicator species, but it has not been implemented monitoring because these animals, when it's microplastic, they ingest very small particles. And when you assess, when you measure technically very small particles, you have a lot of contamination. So there is no, there is no good method actually to assess very small microplastics, but we know what species will be used for that. So it will need probably 2, 3, 4 years before it will be implemented. But normally in the future, there will be monitoring of ingestion of microplastics, yes. And then the second question was about comparison with wastewater treatment and toxicity. The big difference is that toxicity locally may be more important than plastic. But chemicals are more from point source. This is a wastewater treatment plant. This is inputs from a river and so on. This is a local pollution. When plastic is maybe less dangerous locally, but it's going everywhere. I mean, there will be a dilution of contaminants. So, I mean, geographically, it's more localized, but plastic will go everywhere. And if you are based, for instance, in France, you may receive from southern Mediterranean Sea, the plastics. And so the impact of plastic is more, the geographic scale is different than from point source for chemicals.
Thank you. The last two questions. One is about excretion. In the presentation, you mentioned that the plastic is excreted by most organisms. I would like to know if any of the plastic compounds are incorporated in the tissue, or if 100% is excreted. And related to this, we have also a question about the comparison between microplastic excretion and nanoplastic excretion, if it's the same process, or on the contrary, nanoplastic goes into the tissue construction. Yeah. And then, so we have a very technical one on excretion, and then a very general one on the contribution, how plastic pollution contributes with climate change. And these are the two last questions. Thank you.
Okay, so it's I mean, the first one, the two first one are very important, in fact. And so what we can say is that more or less 100% of large microplastics that are ingested will be excreted. But there is a real question for nanoplastics, because nanoplastics may go into, brush powder cells in the digestive tract, in the stomach. They may go in the tissue. So the problem is that we don't know how to assess easily nanoplastics. So it's possible to prepare nanoplastics. It's possible to test nanoplastic before using them. And so there are some data on toxicity of nanoplastic that has been prepared. But once they are in the wild, in the water, I don't know anybody able to measure them properly. There are some papers in very important journals with argument that there are nanoplastics. So if then it's proved, they may be ingested, they may go in the tissue. But for large microplastics, there is no trophic transfer. So the risk is to ingest nanoplastics, but we don't know, we cannot prove that. Then the contaminants, phthalates and so on, they may transfer to the tissue, but if they are transferring, it's because of chemical pollution. It's not the plastic itself, because phthalates is an additive for plastic, is not only used for plastic. You may find phthalates in some other compounds. And so if you have phthalates in the water, it's not only because of plastics. And then also phthalates are released very quickly. Then some other compounds like bisphenol. There was a question for the human food about bisphenol. The point is that bisphenol is used for only 3 to 4% of plastic. So it's not all plastic also. So you may have contaminants in the water, hydrocarbons, PCBs and so on, that are fixed on plastic, that are ingested, then go to the tissue. But the problem is more because there is PCBs in the water than in the plastic, you see? And then about the link with climate change, I will say that there is no direct link. It's not plastic that will increase, that will warm, the atmosphere. But if there is a problem with global change, we may have more extreme events like flooding, like this kind of events. And then these extreme events, cyclones, hurricanes, this kind of extreme events, they bring more plastics in the sea. So it's not the global warming and climate change directly that will affect the plastic pollution, but indirectly, because it may affect, it may generate more extreme events, then there could be more plastic coming to the sea.
Thank you very much, François. Thank you, everybody, for following the first lesson of the BlueMed e-training. I just remind that the next lesson will be delivered on the webinar mode by Françoise Clairaut from the National Museum of Natural History in France. She will address research and monitoring protocols on June 18th. It's Thursday at 10:30 a.m. Central Summer European time. I invite you, I will share with you the link once again to register also for this next webinar session. And as you all know, at the BlueMed Initiative website, the dedicated e-training course web page, you will have all the material, including the recording of this first online webinar, in particular for those who couldn't hear properly, and also there are a lot of people that registered who will follow the entire course asynchronously, so it is for them. And also the forum tool will be enabled on the same website. You will easily find it online. So thank you once again, François, for breaking the ice. I'm sure that next time we will fix all our technical issue, and we are really happy about the number of participants to this first session. And allow me to thank all our BlueMed project colleagues, and in particular Erasmia from HCMR in Greece, who really supported the organization of this e-training. Thank you again to all. Bye.
Thank you very much. Bye-bye.
Bye.